Right. What is current? Electric current.
Current is like the flow of electricity.
Flow of electricity is electric current. Good. Nice. See, it is a flow of charges. Okay.
Yes.
Flow of charges. So when that flow of charge is detected with respect to time, okay, what is it? Rate of
flow of
charges.
charge.
And the charges are actually contributed by the electrons. What is the direction of current?
Positive to negative terminal.
Great. What is the direction of electrons? Negative to positive. Okay. Actually, the electrons are flowing in a circuit. Electrons are more in number. In the negative terminal, more electrons are there, and in the positive terminal, there are less electrons. Okay. So to balance that mismatch, electrons start running from the more electron region towards the less electron region.
Okay.
So electrons move from negative to positive. But conventionally, earlier scientists have always mentioned flow of charges is from positive towards negative, or flow of electric current. Okay. Electric current direction. What is it? From positive to negative, which is actually opposite to that of direction of which one? Electrons.
Flow of electrons.
Exactly. So the charges are contributed. Q is the charge contributed by electrons. Yes, sir. What is Q? Q is charge. So electrons contribute to the flow of charges, and it is measured in coulombs. So what is 1 coulomb?
1 coulomb
How
on
many
the line
electrons? How many electrons should have to contribute to 1 coulomb of charge?
6.24.
25.
6.25 into 10 to the power 18.
18 electrons contribute to 1 coulomb of charge. Then what will be the charge of 1 electron?
Negative something.
What?
Negative 1 point.
1 pointer. Okay.
No, I don't know. Wait, let me think. Charge of electron.
What is the charge of 1 electron?
In the terms of coulomb?
Yes.
1 coulomb is equal to this many electrons.
It is 1 divided by 6.25 into 10 power 18. Okay.
Unitary
so how much would
method.
that be? And that value is equal to 1.6 into 10 power minus 19 coulombs. Okay. How many coulombs? 1.6 into 10 power minus 19 coulombs. It's a very small quantity. Coulomb is a larger quantity of charge. Getting it?
Yes.
You can visibly notice that nearly 10 power 18 electrons should be gathered together to provide a charge of 1 coulomb. Just 1 coulomb. How many electrons are taking part in providing that charge?
6.25 into 10 to the power 18. That's a lot.
Exactly. So the charge carried by 1 electron is very minimal. It's an order of 10 power minus 19. 1 followed by, decimal point followed by 19 zeros, and then only you have your 1/6 place. Right?
Yeah.
Good. So this is about electricity or electric current. flow of what? Charges contribute to the flow of electric current, right? Charges in
Yeah.
the form of electrons. So what is the unit of electric current?
Ampere.
Yes, what is 1 ampere stated as?
1 ampere is the amount required to, oops.
Charge is coulomb, time is stated in seconds. So obviously 1 ampere
Yes.
is 1 coulomb by 1 second. Got
When
it?
1 coulomb of charge passes through by in 1 second, it's 1 ampere.
Yes.
Okay.
And usual conversions. Usually we have some devices working at milliamps,
Yes.
some at microamps.
Yes.
Small electrical gadgets or electronic
Yes.
circuits, they work in this range, and you know it is
10
10
to the
power
power
minus
minus 3
amps.
and 10 power minus 6.
Yeah. The next idea, is current a scalar or a vector quantity?
It flows with direction. So
Okay.
scalar.
It flows with direction, therefore it is scalar.
Really?
What is
No,
scalar?
let me. A scalar quantity is the kind of that is doesn't matter. The direction of flow remains unaffected. No, the direction of flow doesn't affect the quantity.
Any quantity which does not have direction, rather only magnitude, it is called as scalar. Okay. So here in the circuit, if in case current has to flow through these two parts, okay, it's in the opposite direction, so I'm going to nullify it. You won't say that, right?
Yeah.
You say that current is
No.
going from here, 3 amps of current, it is getting split into 1.5 amps and 1.5 amps. Are we discussing about the direction here? No, only
No.
about the quantity. So the direction
Yes.
that we mentioned here is just the flow of current direction, that's all, into which circuit. It could be any way, but it's not going to affect the magnitude. Clear? So
It
it
does.
is
It
a
does.
scalar. Which
Because
one?
if 3 amps are going and then it changes direction, then it becomes 1.5 amps. So
Just
it
because it's
changes.
changing its direction, it is becoming 1.5 amps, or because it is just splitting the number of electrons, it is becoming 1.5 amps.
It's splitting and it's
I'll ask
changing
you in the
direction.
easier way. Here I'm having it split like this, but
Yeah.
when it is splitting like this, will you say that it's changing direction not 90 degree by 60 degree? Therefore, you are going to have the value to be different. Does it depend on direction? Is my question. It gets split. That is there. Does it depend on the direction here? No.
No, it doesn't.
Yeah. So it's a scalar quantity. Okay.
Okay. Okay.
Right. What do you mean by potential difference? Potential. What do you mean by potential first?
Work potential difference is the work by time
What is your potential?
in two different places. My
That is
potential
okay.
is
I'm just
like the
asking you.
maximum.
What is your
My
potential?
potential is the maximum amount of work I can do.
Okay. So the maximum amount of work that you can do is your potential. So something which is stored in you already, right?
Yeah.
So something that you can do in order to achieve something.
Yes.
Your potential or what you can expend from your own self, right?
Yeah.
Same thing as potential here. The potential at a point is amount of work done
Okay.
per
Amount
unit
of work done.
charge. For 1 unit charge, okay?
Okay.
Amount of work done per unit charge in bringing a positive charge, test charge, from infinity to that point. Getting it?
Mm.
So that is the potential. How much amount of work it can do in bringing that particular unit charge, right now, per unit charge. For 1 unit charge, what is the amount of work done in bringing it from positive charge from the infinity to a given point? So at that point, the potential will be that amount. Okay, this is a general idea. But still, this is related to two key facts, two keywords. One is, what is it? Work done and charge. So potential is related to these two factors. What is potential denoted as?
Um,
V.
V.
Okay,
Okay.
symbol is V. V is
Okay.
equal to W divided by Q. This is the scenario.
Q. Yep.
Okay, V is equal to what? W by
W
Q.
by Q.
So the unit for potential is nothing but volt. So 1 volt is equal to,
1 joule by 1 coulomb.
excellent, 1 joule divided by 1 coulomb. So this is about potential. Okay. Now there is another keyword here which is called potential difference. What do you mean by potential difference?
Basically, the amount of work that will be done in moving the positive charge from one place to the other.
Amount of work done in moving a positive charge from one place to another.
To one point to the other point.
From one point to another. So work done per unit charge. That is nothing but potential. So that comes out to be this. That is the potential difference. Here I'm asking about potential difference. Between 2 points you have to mention. From one point to another you can say, or between 2 points. Right? So the difference, potential difference between 2 points you judge. Between a point A and B, what is the potential difference? From one point to another, the amount of work done in moving a unit charge. So 1 unit charge in moving it from A to B, the work that is said to be done. That is called as a potential difference. Earlier, potential was from infinity and all that storyline, right? But potential
Yeah.
difference is exactly between 2 points in the circuit.
Okay.
Clear? So what is
Okay.
this? Is this scalar or vector?
Scalar.
Excellent. Good. So technically, if in case you take up potential as V, which is W by Q, the formula here becomes between the 2 points, now VA minus VB is equal to W by Q. The potential difference between the 2 points is again stated by work done by per unit charge. Clear?
Okay.
So what is the unit of potential difference? It's the same, 1 volt, which is nothing but 1 joule per
Joule by
coulomb.
1 coulomb.
The next idea is interesting, which is called as resistance. So here we will be starting to discuss about Ohm's law. What do you mean by Ohm's law? If in a circuit,
The current flowing is directly proportional to the potential difference across
yes,
the two ends.
yes,
And
exactly.
provided that the temperature and the the environment is the same.
Constant temperature. Good. So I proportional to V or V proportional to I at a constant temperature is called as what?
Ohm's law.
Ohm's law. So here these two are proportional. So I can write V by I will always be a constant as per proportionality idea. V is directly proportional to I means what? When you divide V by I, the value you will always be getting it as a constant value. That is why you say V is proportional to I, right? And
Yep.
that constant value, they have named it as resistance. Getting it?
Yep.
What does resistance depend on? What is resistance?
The surface the surface area or the amount of the space.
Generally, what is resistance?
Like obstruction to the flow of charge.
Good. Obstruction to flow of charge. So what obstructs the flow of charges? So what does this resistance value depend upon?
Is it the space or the size of the?
Exactly. So this is a conductor in which the electrons are moving around. So the movement of electrons, if it is free to flow, free to move, electrons, if they are very free to move, then it has got less resistance. Do you accept?
Yeah.
If they are not free to move,
More resistance.
high resistance. High resistance, or in fact, it doesn't allow, it's an insulator. Less resistance, now you call that scenario to be a conductor. Conductors offer less resistance, like a copper wire, any metal. Usually metals are called good conductors, correct? Huh?
Yes.
High resistance is offered by insulators. Insulators which does not allow electric current to flow through it, right? Those are called
Bad
insulators, and
conductors.
usually non-metals are all bad conductors.
Insulators.
Insulators, right? Not, you can't say non-metals, sorry. Some of the non-metals even conduct. There are
Like
insulators.
graphite.
Yeah,
Okay.
it conducts. Right.
Insulators
So
are just bad conductors.
even liquids and gases, some of them conduct electricity. They charge, they ionize, and then they conduct. So that is also there a scenario. So let us forget about that. Here, in
Okay.
general, wood is an insulator. Plastic is an
Plastic.
insulator. Yeah. Okay. Right. So there are some which allow the resistance to build up, and because of the higher resistance, but not very so high resistance, the charge or flow of charges will be there, but at the same time they will create a heating effect. That scenario is also there. So some elements are there, alloys, some alloys, they are created such that, okay, they offer resistance so that the coil gets heated. Okay, like heating devices, geysers, normal heaters, toasters, iron
What's the
box.
difference between a geyser and a heater?
Okay, let me write it as a toaster. Okay,
Okay.
yeah, toaster, iron, all of them. These devices which give out heat energy are having coils in them which is made up of some particular type of alloys which offer resistance. The resistance value will be higher than that of conductors but lower than that of insulators. So technically they allow the current to pass through, but still it is offering some kind of resistance because of which some kind of friction like thing happens, because of which the equipment gets heated up. When the electrons are going to collide at a higher pace with each other, there will be a heat energy which is getting created, right? Particle collision. So that heat is only coming out as the heat energy produced by those equipments. Okay.
Yes.
So this is with reference to resistance provided or offered by some heating equipments. So this is about the electron flow we are discussing, right? Now you tell me,
Yes.
how should a conductor be designed in order to make this resistance to be
Minimum.
lesser?
Like larger, make like larger surface area.
Cross-sectional area.
Yeah.
Okay. So
And
resistance
then
is inversely proportional to area of cross-section. If the area of cross-section is
yes.
greater, if it is very thick, then electrons have more space to move around, so easily they can flow.
Yeah.
If there is greater the area, resistance will be less. It will easily allow the current to pass through it. Okay. Same way, resistance is proportional to length of the conductor. If you are designing a conductor which is like having a longer length, then what will happen? It has to travel twice the distance. Imagine its length is increased. So obviously the resistance is also going to be greater there. The electrons have to have the hardship of traveling through the second half as well. Imagine you are having your classroom in your school in which floor?
Mine is first.
First floor. Huh? How many floors
Yeah.
does your building have?
3.
If they shift you to the third floor?
No, not allowed.
If they shift you,
No.
it's going to be a difficult process for you to reach there, right? Same with the
Yes.
electrons also. Depending upon the difficulty in reaching only, you're calling it as resistance provided by the conductor. So technically, when the length is increased, what happens? The resistance also increases. So it is directly
Increases.
proportional. Okay.
Okay.
And the last part is about the material. Just now we discussed metals are all good conductors. Some of these materials are all non-conductors. Why are they non-conductors? Because
Because
these, huh, so they
they
have
don't
an
absorb.
associated, yeah, they have an associated property of free flow of electrons. Metals have got free electrons in them, whereas these materials do not have free electrons in them. And in metals itself, you have got copper to be a very good conductor, whereas magnesium and all will be in the next list of it, right? So, conductor's resistance actually depends upon which material you are using. See, the same thickness, the same length I can use, but I'm going to use a copper in one and wood in another. The resistance depends
The
totally
wooden
upon
one.
what the material, right?
Yeah. Yes.
So the material, the property associated with a given material, it is called as resistivity. Okay.
Yep.
Resistivity is denoted as rho, and the R value is directly proportional to resistivity. So R is equal to rho into L by A is one of the formulas which you will use to find the resistance of a conductor, because on these three ideas, it is dependent. Okay, the value of
Yep.
resistance depends upon these three ideas. One is rho, the other one is L, the last one is A. Three things. Resistivity, this is depending upon the material. The material's conduction is insisted by which one? Resistivity. Now, about the units, just now we discussed R value to be equal to rho into L by A. Do you know what is the unit for resistance?
Ohm. Ohm.
It is ohm.
Ohm.
Ohm is denoted like this symbol, right? Then what is the unit
Yep.
of resistivity?
Uh.
We can rearrange this formula. Rho, I can write it as R into A divided by L. Can you? A goes, L by A when it
Yes.
goes to the other side becomes A by L. So,
Yes.
what is the unit for resistance? Ohm. What is it for area? Meter square. What is it for length?
Yep.
Meter. So, when you cancel out, what
Meter.
will be the unit?
Ohm meter.
Exactly. Got this?
Yep.
Good. For resistance, there is one another formula which we saw right now. What is it? V by I, which is Ohm's law.
I. C.
Right. So what is that you can state from this? 1 ohm. What is 1 ohm?
1 ohm is equal to 1 volt by 1 ampere.
1 ampere. If a current of 1 amp flows,
The resistance of a conductor is said to be 1 ohm if 1 amp current flows through when the potential
that
difference
circuit
is
of potential
1 volt.
difference of 1 volt. Okay,
1
but that
volt.
can't be given as a definition at all. Please note that. Okay.
Why?
Because this value of ohm, this changes with respect to the temperature. You can't have it to be a fixed value. Clear? It's varying.
Okay.
So usual definition of relating it with potential and current, you can't give it. Rather, what is resistance? Resistance depends upon these three factors. So when you discuss about 1 ohm, you discuss about these things. About the resistivity, length, and area of cross section, because this is fixed. Clear? A bit of wire or any electrical equipment that you are using, you know the coil's length inside that electrical equipment, area of cross section, you know that it's a fixed value, yes or no? And you always know the material with which it has been designed. So can you fix out the value of resistance for a given equipment? Yes. R is fixed in a circuit, whereas I and V tend to change. Got this idea?
Yep.
Just fix it in a circuit. For a given equipment, the value of R is always fixed. If they give you the value of R is 5 ohms, it will be 5 ohms throughout. Its value of resistance is not going to change at all. Clear?
Yeah.
According to the value of resistance, the amount of current I value and V value that it allows to pass through it or across it, that is going to change. See, for instance, I have a circuit of 6 volt, okay, and I have a bulb or any kind of resistor. Imagine this is a resistor, right? Any electrical equipment, even a small piece of wire, has an associated electric current flowing through it, right?
Yeah.
It has got its own charges flowing through it, so it will be offering a resistance. And I'm saying the fixed value of resistance by the calculation of these things, this one is some 3 ohms. Okay, I know the battery to which I'm connecting this 3 ohms resistor. The battery to which I'm connecting it is 6 volt battery. Now, what changes in the circuit exactly? The current. Current is how much? I is equal to V by R. So 6 volt divided by 3 ohms. So you get I value to be what? 2 amps. So how much current will flow? 2 amps of current will flow. So the same thing, but now I'm connecting the same 6 volt to a 12 ohms. How much is it? The battery or the circuit that I'm connecting here, the resistance is offered by it is 12 ohms. So what happens now according to the 6 ohms, which is getting changed?
1 by 2.
So I is equal to what? V by R again, and V is what? 6 divided by 12, which is equal to 1 by 2, which is equal to 0.5 amps. So same direction, how much is the amps now? 0.5 amps.
1.5.
So depending upon the equipment that you connect to the battery, the amount of power withdrawn by the battery, the amount of current, the charges withdrawn from the battery is going to vary. You're getting it now?
Yes.
Great. So this is the scenario. Clear about this?
Yep.
So is this value going to change? No. For a given equipment, the value of resistance is going to be always fixed. Getting it? Right. So in case of our household circuits, you have various devices connected. You have a bulb, you have a fan and all that. So they are either connected in series or in parallel. So if they are connected in series, that is one after the other. Series connection means one after the other, they are getting connected. So the same current only will be flowing. It has to pass through and it has to flow. So the same number of electrons are going to flow, right? So the same current, I will be the same at every point in case of a circuit, series circuit.
Series.
But the value of potential across each of these devices depends upon which one? Depends upon the resistance. Getting it? If this is of resistance R1, this is of resistance R2, this is of resistance R3, okay? The value of potential is going to be different for each of them. Imagine this is the potential across this one. Across this one, I'm connecting another voltmeter. Across this one, I'm connecting another voltmeter. Voltmeters are connected in parallel in a circuit to judge how much is the potential difference across those 2 points. Across these 2 points, what is the potential? Across these 2 points, what is the potential? So across the 2 points, the potential that you have to judge, that should be judged By using an
Parallel voltmeters.
Exactly. So here the source of power is from this battery which has been connected, okay, which is V, which is
Yes.
offering the total potential difference, okay. And you know this potential is only going to get split between these three resistors. So V is nothing but equal to V1 plus V2 plus V3. Likewise, how many of our resistances are connected in series? What happens? For each of them, the potential is going to get split. For instance, if in case I'm connecting 6 volt, maybe each one of them is going to get 2 volt. If in case all three resistors are the same value, it will be 2 each. If at all the three resistors are different, maybe this one will take only 1 volt, this will take 2 volt, this will take 3 volts. So, but the total is going to be 6 volt. Getting it? The potential is going to get split among the resistors according to the resistor's resistance value. Depending upon R1, R2, R3, their values, whichever is greater or lesser, accordingly you will have the potential to be split according to their requirement. Okay. So V is equal to V1 plus V2 plus V3, and you know the formula for V. What is it? V is equal to IR. So I into R. This R is nothing but the resistance of this entire set. Imagine these are the points A and B. Across AB, the total resistance offered by the circuit is called as IR. And here you have the resistance value as RS because we are discussing about series resistances. Okay. Equivalent resistance of these three resistances together across AB. What is V1? Same formula. I is the same.
Okay.
Which is varying. What is V1?
6.
No, not the value. I'm just asking about here V is IRS. Same way V1 will be
IR1S.
IR1.
IR1. Yeah.
Yeah. Plus next one will be IR2. Next one will be
IR2.
IR3.
IR3.
So you can take I common outside. You will end up with R1 plus R2 plus R3, which is IRS. I will get cancelled. You will end up with RS to be equal to what? R1 plus R2 plus R3. It goes on.
R3.
How many ever equipments you have connected in series, all of their resistance values you can add up together in order to get the equivalent resistance. Getting it?
Yes.
Right. The next idea is about a parallel connection. A parallel connection is one in which you will have the current to flow after getting split. See, this is R1, this is R2, this is R3. And the current, what happens to it? The current I that goes here, it gets split as I1, I2, and I3. But across these 2 points, what is the potential across A and B? It's going to be the same. So in the circuit, if it is V, then V potential across R1 is V. R2, it is V. R3, it is V. Because all these three are connected across AB only. And across AB, you have got the potential fixed as V. Correct?
Yes.
So it has the same potential, but current gets split. What is the scenario here? Same
potential, but the current gets split.
So potential is the same, we use V, but the current is getting split. How? I is nothing but equal to I1 plus I2 plus I3. Correct? The entire current I, which was flowing in the circuit, has got split into 3. What is I? I is equal to V by R. So V by RP. All of them are connected in parallel, so I am giving RP to be the equivalent resistance between the 2 points AB. Okay? Instead of these 3 resistances, if you were to connect one single resistance, that will be RP. So what is I1? As per the formula V by R1. This will be V by R2.
V by R2, V by R3.
So V, when you take it out common, what will you end up with? 1 by R1 plus 1 by R2 plus 1 by R3.
Plus 1 by R3.
So we can transfer V. Okay. So 1 by
Yes.
RT, please remember 1 by RT is equal to 1 by R1 plus 1 by R2, it goes on. Getting it? 1 by RT. After you find this 1 by R1 plus 1 by R2, what is that you have to do? Final answer, you have to reciprocate to get your RP value. Yes, so
Yep.
these two are two interesting formulas using which in a sequence of resistances connected in series or parallel, you can find the equivalent resistance value. Got this clear? So I guess we
Yes. Got
have
it.
dealt with pretty many formulas for today. You have one more thing which is called conductance, which is nothing but reciprocal of resistance. That's all. What do you mean by conductance? Obviously, it allows
The
current to pass through.
conductivity.
Conductivity. Resistance means you said
Resistivity.
it is the obstruction.
The obstruction. Yeah.
Yeah.
So
So not the
conduction will be
obstruction, there is. So it is the
the free
allowing
space.
or allowance, right? Yeah. So conductance is
Yes.
nothing but reciprocal of resistance. And so conductivity will also be a reciprocal of resistivity that way. Okay. So what is the unit of
Okay.
conductance? It is ohm inverse. Ohm inverse.
It says
Or it is otherwise
Simon
called Simon. Simon or Siemen with symbol
S.
S. Yeah. Got it?
Yep.
Right. I guess we are done with this. So all the formulas have been discussed.
Yay.
Regarding this, we have to discuss about the problems. Okay. There are pretty many problems which we will be
Okay.
discussing later. One second.
Okay.